Hello everyone, are you able to hear me? Hi, is my voice clear to everyone? Hi, is my voice clear to everyone? Are you able to hear me? Hello. Hello. Are you able to hear me? Great. Great. Now your answers have come now. Okay. 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 Great to know you, Shashi. I'm happy that you were able to install Java. All right. Great. And Eclipse also. All right. So looks like your answers are coming little late. That is why there is a delay. Good, good. So how many of you have just raised the hand if you have tried SBFS based on our discussion yesterday? So only Rohit and Srinivasan has tried the. All right. The quiz you may, yeah, you must try quiz. Okay. This one. But you may not be able to complete it right now, but you must give it a try. Okay. Yeah, yeah. Kamal, when I say yesterday, I meant last week only. All right. There are so many questions. Before I begin, there are so many questions. So let me just go through the questions once and then we can start. All right. Okay, okay. Okay, so Sashi's question is there a quiz two? Not yet, not yet. The quiz one is actually will be up to today's class. So it will cover first, second, and third session, and then there will be other assignments. All right, let's take this question from Mukesh. Mukesh asks that what is the difference between the three? File system image, edit log, and metadata. Okay, so metadata is from the user perspective. When you say metadata, metadata means the name of the file. Okay, so here we are talking about data that is stored in name node. Okay, what is stored in name node? As we had already discussed here. Okay, so this screen will make it far more clear. So the name node's duty is to store all the metadata about the file system, and this metadata means the name of the file. So whenever we are adding a file or creating a file through Hue, we are adding it to name node. Okay, okay. So this every file we are adding in Hue is adding to the metadata of name node. This metadata basically has got file name. How many replica do you want? What are the block numbers? And on which machines are those blocks stored? So this is metadata. Second is the file system image file, FS image. What is FS image? The whole image of the file is, I think this diagram will make it clear. So metadata is equal to the namespace image or file system image plus the edit log. Okay. So periodically the name node keeps putting the data into the file system, okay, which we call snapshot, and very frequently, as and when every transaction is occurring, it's adding the information into edit log. So when you have to recover a name node, you have to combine the snapshot, you have to combine the last taken snapshot and the edit logs. Only then you will get the current image of namespace. Okay. In case in case in case the name node is down, in case the name node is no longer available, to recover the name node, you will have to combine file system snapshot or file system image with the edit log, and that's how you will recover the metadata. So in simple words, fs image plus edit log 1 plus edit log 2, all right, will lead to the metadata. I hope that is clear now, Mukesh. So snapshot is file system image. So periodically, what namespace does is, name node does is, whatever metadata it has, it will save it to the disk. Okay, that's called a snapshot. Snapshot is like a photo. All right, so it takes the snapshot of the full metadata, and that snapshot is known as file system, FS image or file system image. All right. So that was one question. Now the next question is, okay, all right. So yeah, so there has been a fiasco on my side. All right. So while deleting the old Cloud Lab servers, I actually deleted the website, and because of which, we had a loss of 1 week's data. Okay. So whatever changes we did since 21st October are lost. And also the assignments, if you had finished, you might have to do it again, because all the data which was gathered on the server for last 1 week has been lost. Although we had backups, but they too got deleted. Okay. So yeah, it was a big mistake. Yes, I'm referring to the quiz. So you'll have to attempt the quiz again. Yes, we covered up to this slide, Peter, isn't it? We also saw the file locations. We also executed this command. Now, Srinivasan's question is, what is an edit log? Edit log is an edit command that you wanted to create a file. So that's the edit log command. It goes into the records, just like if you know a little bit about accounting. So there's a general keeps on going on, and there are vouchers. So basically, file system image is periodical backup of this metadata store, and edit log is continuous. So periodically, the snapshot plus basically, because taking the snapshot of the whole name node is costly. Therefore, what name node does is, as and when, so this is done periodically to take the snapshot, and these are the edit logs as and when things are happening. A folder is created, file is created, and so on. Right? All right. Okay, so there's a question from Kamal. Kamal, have a look at this last session's video. I guess you have missed the last session's. If you go into session number two, okay, yeah, we can have that. You can go over that, and it'll be good. All right. So same is for Peter. Peter, if could you please go through the video? I'm not sure. I think the email was must have been sent to you. We can discuss it after the session. All right. I think there has been some mistake that you did not get the invite for the session number two. All right. Now name node. Okay. All right. Murkesh, this. Can you give more information on current cluster setup? We had discussed it in the last session. If you go into the last, you can see here. Okay, you will from 2 minutes onwards, 2 hours onwards. Yeah. So I've described what is there. All right. So if you have any specific questions, I would love to answer. All right. Now, Kamal's further question is, name node keeps metadata in the RAM. Yes, so it keeps in the RAM mainly, and then periodically it creates the snapshot, puts it into the disk, and then as and when the things are happening, it's updating the RAM as well as updating the edit log. Because in case the machine turns off or something happens, everything in the RAM is lost. Therefore, as a backup of that, it keeps it in the disk. All right. So Anand's question is, um, I couldn't see the files in VATI under home. Okay. This. So there are two different things we are talking. So whenever there's a big confusion which people have here, one is console login. So let's say we are logging to console, or maybe let me just take it to S3. Okay. So this is a big question everyone is having. So if you log into console, all right, let me just log in everywhere. This okay. Oh, it's not working. I'll show you. Okay. So okay, so here is one folder you can see. So right now we are logged in into h1.cloudxlab.com. This is the h1 is one of the servers, and that's where we are logged in. Okay, so this is how you can simply start working on any of the machines if you know a little bit about console. Now let's open another one. Let's say we are opening h3. Okay, that's also another server we have. That's also another server we have. Okay. Okay. Now, this is H3 .cloudxlab. We have logged in into this. So this is a normal machine. Before Hadoop or anything, this is how it looks like. And this is like, this is not, nothing to do with the Hadoop or big data as such. Okay, this is just local file system. The way you have your local computer, it is that kind of machine. Now, whenever we create a file here, we are creating on this machine. So this X is not visible anywhere else. You can see that. Okay. So whatever files are there on this are not here. Okay. Now, this is another file system called the HDFS, as we have discussed. And in HDFS, you can, again, let me exit from the admin and let me log in into a normal user. All right. Now you can see that there is file browser in this. So this is HDFS. So any file you create or any folder you create, it's going to break it into blocks and then put it into data nodes. And data nodes are H1, H2, H3 again. So you can see that whenever here home, the home looks very different, right? Home has different set of file, while the home of this one contains X, this one contains something else. All right. So these are three different file systems. If you create something here, it will not be visible here. But if you want to see what is there in HDFS, you can also use a command called Hadoop fs -ls. Okay. Now these are the same file. No matter where you execute, no matter whether you are executing this command on first machine, second machines, or third machine, you will get the same result. All right. I hope this is clear to you. What is the command to get out of ready? You type exit. Okay. This is a standard Linux terminal which is running in the browser. Okay. All right. So is that clear? So Anand, what was your question regarding? I cannot see file. Okay, okay. I think that is clear now. All right. So ls command is not listing file because it has no file. It has only one file. Good. Okay, what is the command to come out? Okay. All right. Another question is, so from H3 local directory, can we move files to H1 from command line? Yes, you can use something called SCP. SCP is a way to securely copy the files between Unix machines, okay, or Linux machines basically. So you can say SCP and your login, whatever login is given to you, and then you can say H1. First, you have to log in into H3 and then say SCP login at this. Okay. And then you put colon and then put folder name, my folder. Okay. And then, okay, sorry, not this way, this way. So my folder and you copy this. I'll show you. So let's say we are on H3. This is H3. You see H3. We are here, not this. We can say scp, and let's just create a file here. Vi on nano is for creating, no, nano or pico. All right, nano pico is not there. Let me just download a file from hdfs then. Let's say I'm downloading a file from hdfs. Copy to local. So this I'm downloading a file from hdfs, and ignore the warnings for now. scp this, okay, and I'm trying to say copy the file to another machine, which is h1.cloudxlab.com. Okay, now it'll ask me for password. I'll just keep my password ready. Alright, it is not allowing you to do this. Alright, okay, we need to have a look at it. But in the meantime, if you have to transfer something from one machine to another, you can put it in HDFS and then download it elsewhere, because HDFS is same everywhere. All right. Ideally, SCP works, but for now, use HDFS for this. Okay. And how do you put in HDFS? Using Hadoop FS5 command. For Ambari, yes, we installed the server software in the name node. We basically installed Ambari, and Ambari installed everything. Now, another question from Srini is, yes. His question is, can we create a folder in any node? So you can use, basically you will have to log in into the terminal, and then you have to say mkdir. Okay, and in case you want to create a directory in the hdfs, okay, then you have to say mkdir and then, all right. Is that clear? Is this what you wanted to say? Yes. So Dilpu's question is, file uploaded via Hue will go into HDFS and not local, right? That means it will not show in LS and only show in Hadoop FS minus LS. Exactly. You got it correctly. You got it exactly right. All right, Murkesh, you have installed. So did you get the answer about this thing? So we did not. We basically installed Ambari server on one node, and Ambari installed everything else. Okay, Ambari installed name node, data nodes, and all the things that are required for cluster. Okay, okay, okay. Okay, so Anand is asking if we can increase the timeout setting. Let me check if we can do that. Okay. All right. Good. Good set of questions. Moving on. So Dirpu's question is, does that mean Hadoop commands are same as Unix command with the prefix of Hadoop FS? Not most of them are there. Most of the commands are there. Same. Have a look at have a look at Hadoop FS. Okay. If you just type Hadoop FS, it will give you the full list of commands. So you can see Hadoop FS. Okay. You can see that these are the commands which are supported. So if you want to know about any of the command, you can try Hadoop FS and that command name. You see that? Let's say there is a command called get merge. I want to find out a help about it. What you can do is I can write, yeah, remove mine dash from is. So you can see that it has given me the help on merge. You can see here. All right. It says that, sorry, yeah. It says that get merge gets all the file in the directory that match this. Okay. So similarly, you can, let's say, move from local was one of the command. Now it tells us that it is same as dash put except that source is deleted after it has copied. Okay. Let's say put. So it is showing you the help about this each command. All right. Good. Good set of questions. Now let's start with our today's agenda. So today's agenda is to understand MapReduce. Okay. If you have any questions before, you can ask. Let me just grab a water bottle. All right then. So is my voice coming through fine? Great. So today, now we are going to discuss something called compute engine. We have discussed in detail about Hadoop, the Hadoop distributed file system. Why do we need Hadoop distributed file system, and how does it cater to all the kind of requirements? So in quick summary, Hadoop distributed file system runs on many machines parallelly, where it stores the actual data on many machines while metadata on one machine along with various kinds of backups. And then if any machine goes down, it can take care of by recovering it. Now, if you have 30 machines, you have already installed the Hadoop distributed file system on that. And the files are broken into blocks and stored. Now, let's say you want to do the computation on top of this data. If you have to do any computation in Hadoop, there are many things that you want to know. First, since Hadoop runs on many machines parallelly, that means that the computation has to be done parallelly on all these nodes. Also, the data is already on every node. Therefore, therefore, it is already that means when you're doing the distributed computing, you don't have to transfer much of the data because blocks are already available on every computer, every node in the cluster. So we will go into the details how the magic happens. Okay, so the computation, the heart of the computation is yarn in case of Hadoop. Hadoop basically does the computation on using yarn. So whenever you have to get something done, you tell Hadoop to get it done, and it will get it done for you. Okay. Now, what is the point of a new computation engine? Let's understand it. What exactly is the purpose of new computation engine? Because if we remember correctly, this is what our existing operating system did. All right. Existing operating system also executed our program and did the job. But why do we need a new computation engine? That's something which we need to understand first. All right. So let's see. So if you have 1 GHz processor with a 2 GB RAM and you have to sort 1 TB data, and a terabyte is close to 10 billion names having 100 characters each. Okay, so we have got 10 billion names and we want to order these 10 billion names. What will we do? Sorry, how much time do you think it will take for an average computer? We have got 10 billion names in a file and we want to order them. How much time do you think it will take? Anyone? Anand says it will take 6 to 7 hours. Kamal says 45 minutes. Dilshad says 7 hours. Alright. It generally goes up to 10 hours. Okay. On really fast computers, even the really fast hard disk, it might take 6 hours. But it will actually, it took, for me, it took more than 10 hours. Alright. It took more than 10 hours with lot of optimizations. Alright. Now, what is wrong with 6 to 10 hours? Are you happy with 6 to 10 hours when you have to sort 1 TB data? Alright, so what is wrong with that? What is wrong with this is we might require a faster sort. We might require big data sorting, as in bigger data than 1 TB. You might require 2 TB. For 2 TB, time taken might be more than double. Okay, and we might have to do it more often. We might have to do it more often, as in every 2 hours we might have to do this. All right. Now the okay. So these are the limitations. So as opposed to our understanding, when you have to sort 1 terabyte data, we generally have this impression of sorting that it finishes really, really fast. Okay. So those who are from database background, whenever you create an index on a table, the sorting starts. Okay. Now, if you have let's say you have 1 terabyte data in a table and you want to create index on it. Okay. Now you're creating there's only one column containing 100 bytes and there are a billion rows. If you create an index on such kind of table, it will take really, really long time. Okay. It might take more than 6 to 10 hours. Okay. So when we deal with this kind of data, even computation becomes impossible. At a lot of times, this kind of computation may not be acceptable to us. And that is why, so sorting being a very important problem, sorting is a very important problem. Okay. If you take any kind of program, I mean, most of the work is done using sorting. So let's take an example what how important is sorting because that is needed. So how important is sorting? Okay. So where do you encounter sorting? Anyone? Where do you encounter sorting? Sorting means ordering of the data. What kind of work do you do on your computer when there's a sorting happening? Murkesh says report generation. Okay. What is specifically in a report generation? Okay. Anand says that if we have to, when we need to fetch top 10 results, good. When you want to present the data in a different format. All right. So, question to you is, does sorting matter to you when you have a query like this? Does sorting matters to you when you have a query like this? Okay. So what if table is indexed and table is not indexed? So indexing is sorting, by the way. Whenever we create index under the hood, it creates sorting. So if table is not indexed, this query will be really, really slow. Which means sorting helps select query in the following manner. By having indexing, to do the indexing, you require sorting. All right. Now, next is select star from table 1, table 2 on x equals y. Now, do you think sorting matters here? Yeah. When we say select star from table 1, comma table 2, we are joining the two tables. Do you think sorting matters here? It does. It does. Under the hood, when we do sorting, the data, whenever we do joins, the database does sorting. Whenever under the hood, whenever we are doing the joining, it is internally doing the join. Okay, sorry. Whenever we are doing the joins, it under the hood is doing sorting for us. All right. So what happens is when we are joining two table like table 1 and table 2, what happens is the table 1's data gets sorted based on this column and table two's data gets sorted based on this column and then they are joined together. If there is no index, if there is an index on this table, table 1, then it's good. If it's not, if table 1 is not indexed on X and table is not indexed on Y. It tries to first either scan and then, or it tries to sort the data to join. Second is when we say group by. Select star from table group by X, or here I'll be, okay, something like this. Is there a sorting happening in this query? Anyone? Correct. So there is a sorting that happens under the hood. So whenever you say group by, it essentially first sorts the data and then after that it scans the data from top to bottom and prepare the groups. Preparing groups in a data already sorted is far more easier. So if you are grouping a data on the same field on which it is sorted, it becomes very straightforward. Okay. Now, so when I say select star from table, order by ID. Now this one, is it impacted by sorting? Of course, yes, because order by is blatantly a sorting. Okay. Now the idea is that sorting is an important aspect. Probably every program, whether simple SQL queries or complex problems such as finding the path in a map, okay, finding a path in a map or finding other kind of information across the globe, all of those are impacted by sorting algorithm. So sorting algorithm kind of is one of the basic computer science problem. Okay, most of the algorithms use sorting in one way or another. Okay, so that is the reason why sorting is such an important issue, and that's why I'm also discussing it. And also, if you will go into the detail, the MapReduce is nothing but a big sorting engine. All right. Now, sorting is such an important issue that there is a website called Sorting Benchmark, in which various companies compete in sorting algorithms. In one of the years, Hadoop has won that competition, and Google set a very high standards in 2011 by competing in that and solving sorting 10 petabyte data in 6.5 hours using 8,000 computers. Now you can see that the only way to go forward to sort bigger data is by utilizing multiple nodes the way Google did. All right. So, because on this machine, you cannot do a faster sorting than 1 terabyte data. There is no formula around here. It is something which has come from running the program on different computers. Okay. There is no formula here. So, the important idea is we talked about two things. First, sorting is a very important aspect in computing. Second, sorting takes a lot of time on a machine. Therefore, there is a competition around the world to beat most of the sorting algorithms and make it really fast. And that's why every year there is a newer algorithm of sorting which keeps on getting published. And that's also the reason why MapReduce is essentially a sorting machine, big sorting machines. All right. So Srinivasan has lost the audio. Is everybody else able to hear me? All right. So Murkesh's question is, are we discussing Yarn or MapReduce? Okay. We will first discuss the MapReduce 1.0 as it was. Then we will get into the details of MapReduce 2.0. And why I'm doing it is because it's easier to understand first the MapReduce 1.0 and then understand Yarn. Okay. All right. So the above portion of this diagram we had hidden. The lower portion was HDFS. So you can see that there are many data nodes and there is admin node. This is the HDFS cluster. On the upper side, you see this is what is the MapReduce 1.0, which is there is a job tracker and there are many task trackers. And what does it mean? So in a cluster, you want to get something done, and you have so many machines. What you do is you assign the work to all those machines, let them finish the work, and then report back saying we are done. And that's what is the role of MapReduce engine was. So you would give your MapReduce task. I mean, we'll talk about what is MapReduce task. Whatever assignment you want to give, you will give it to job tracker. Job tracker will assign parts of the work to each task tracker. Okay, and those task trackers will work on it and then report back to you saying that we are done with this work. Okay, and this job tracker will report the overall status. So you as a client, or you who is using the command line client, ask job tracker. So you ask the client and client asks job tracker to do something, and this job tracker will break that into multiple work, break that into parts, and assign it to various task trackers. Now task trackers will work on it. Task trackers can execute many tasks in parallel and will do the job and report back to the job tracker, and job tracker will report back to you saying this much of the work is completed, and these are the things which are yet to be done. So job tracker reports the overall progress to you. All right. Now under the hood, what it used to be that user Now, first question you will have when we talk about assignment, that so which all machines does the job tracker give the work to? Does it give the work to all or only some? We'll go into the detail as we go further. All right. So it's very simple job shop floor model where there is a supervisor and there are many workers. So you, whenever you have to assign a job, if you have to give the work or assign the work, you will assign it to supervisor, and supervisor will get it done with the from the workers on the shop floor. It's a standard model to avoid confusion. This is what is done generally in any shop floor or even in the restaurant. There may be many people involved, but there is only one person involved with you for the food serving. Okay, so now these are the following steps. How it goes. I mean, never mind if you don't get it now. We will go into the details again, and this is just for the basic overview. Okay, so there are a few more important things here. So when you are assigning the work to a job tracker, you also give a file. That this is the file we want to process. We generally used to assign the work to MapReduce, the work which involves a lot of data. And and whenever we are assigning the work to job tracker, we also tell the job tracker that, see, this is the file which we are going to process. Okay, please take this, please run my program on this file. Okay, please run my program on this file. And job tracker tells you that, okay, I will not be running on the full file. I will be running many instances of your program on parts of the file. Okay, so you tell job tracker that please run my program on this file, and job tracker runs your program on many nodes. Okay, your program, it makes a copy of the program and it runs on many nodes on parts of your file. And how does it do that? Because the parts are already broken in HDFS, right? Your file is already broken into blocks. All right. So whenever, again, let me take a step back and repeat whatever I said. So when you're assigning work to MapReduce, you tell the MapReduce that, hey, there is my file. So first you upload your data onto HDFS. Generally, that is how you do. Although without data is also fine, but let's just go with it. So first you upload your data into HDFS, and then while giving the work to job tracker, you tell that, hey, here is my program. Can you run this program against my data which is located in HDFS? Now, job tracker takes that work, and what it does is it runs your program on every block of your file. Okay, and where is every block located? On the data node. Okay, and data node, there are many data nodes in the network containing many different blocks, and job tracker first finds all those nodes which contain the blocks of your file. Okay, not all nodes contain the blocks of the file. So it will first try to find out what all nodes contain the blocks of the file and which ones are nearer or, or nearer to the data. In case sometimes it's unable to find the free nodes which contain your blocks. Sometimes it might be that all of the blocks are busy. There is only one node which is free, and that node may not have your data. Okay. other nodes might be having those blocks. In those cases also, it can execute your logic, but there'll be a transfer involved, right? So it takes your work, it takes your program and runs it on all those nodes that are either closer to the data or are having your data already, and then assembles the work and gives back to you the result of all the program runs it has. Okay, so I hope this is clear. Now let me describe the same process again. So you as a user first upload your data file onto HDFS. DFS means SDFS here, Hadoop Distributed File System. And then prepare your program. You have already written a code which will run against the data. Okay. Now you upload this program, and in the this program is written in the form of map function and reduce function. You basically write two functions. We will go into the details of what is there in the map function and reduce function, and then user submits the job to the client. Now the client figures out where all the data is located. Actually, this diagram is not really correct. It is pretty old, so we will change it as we go forward. Now, the user submits the job. There's something called splits which is created on top of every block. Block is a raw data, and on the raw data, we create something called split. Okay, and then basically we prepare the data for the input for the programs which user has submitted. Now this job tracker, when this client submits the job to the job tracker initializes something called a queue. Okay, this queue keeps track of what work is given to which node. Okay, which task tracker is working on which piece of data, and this is what this job queue keeps a track of. In case This is done so that in case one of the task tracker goes down, the data could be recovered. Okay. The same program will be run on another machine, and the still it will give the correct result. So job tracker initializes the job. It's like a job queue. You must have seen in the shop floors that assignment is made for each individual worker, and then there is a note written in the job queue that who is working on that piece of data. So, so there are three three tasks in this job queue. First task assigned to first task tracker, second task tracker, third task tracker, fourth task tracker, five task tracker. So five task trackers are working right now. Now, in case any of this task tracker goes down, there will not be a heartbeat. Okay, so task tracker keeps track of all the job tracker keeps a track of all the task trackers. It keeps pinging, or it keeps receiving pings from task tracker. Task trackers are supposed to ping job tracker all the time. They need to inform job tracker about their status. In case job tracker does not receive ping from one of the machines for some time, it assumes that machines to be dead. And if it finds out that those machines are dead, it just assigns that work to somebody else. Okay, so the moment job tracker does not get the task tracker's ping, as in job tracker realizes that one of the task tracker might be down, it assigns that work to other task tracker immediately. Okay, and discards all the work done by previous task tracker. All right, this is how it looks like. Again, so we talked about few things. One is that client assigns the work. Client asks job tracker to do something, and while it's asking job tracker to do something, it gives two things. One is what to do and what is something. Okay, and that something is in the form of big file. That's the input data, and the do. do something is a big file, and do is the program, and the program you write in the form of MapReduce, basically two functions called MapReduce, and how they'll get executed we'll talk about later. So job tracker job tracker launches the user's program onto all the task trackers which contain the blocks of the file, and those task trackers will do the job and report back to the job tracker, and job tracker will inform the end user. All right. So yeah, now we just discussed something about Hadoop 1.0. In Hadoop 1.0, the only work that could be done on these computers in the cluster was MapReduce. If you have to do something else, you will have to you cannot get it done. Okay, so that was the only kind of work that was possible on on the cluster. Okay, therefore there was lot of things that MapReduce was doing. First, it was taking care of these assignments. It was taking care of these assigning things, as well as it was taking care of executing maps and reduces. So, basically, the map reduce was not good enough earlier because it was doing both the things. All right. So, as part of Hadoop 2.0, they broke MapReduce into two parts. One was just that program, the way you structure your program, the way the semantics of an exact execution is done, and second, the resource management part. Okay, resource management part, as in finding which machine is free, which machine is busy, in case machine is down, get it executed somewhere else. Those kind of semantics were separated out from the heart of MapReduce. So MapReduce became Yarn plus MapReduce. All right. So Murkesh, you mean this slide only, or you mean previous slide? Okay, slide number 35. All right. Now the MapReduce was doing both the works. It was taking care of finding which resource is free, which resource is busy, and also tracking which resource is overloaded. So, along with that, it was doing everything, which means there were no other processing models possible than MapReduce. Okay. Okay, so MapReduce was broken into MapReduce, which was just the data processing engine, and Yarn, which became the resource management, cluster resource management. So the parts which were responsible for managing the resources, as in which machine is free, which machine is busy, that kind of resource management, those were taken out, and we started calling them Yarn. Okay, and Yarn was exposed to all others, as in other data processing engines can utilize Yarn just like the way an operating system is utilized by many programs to do various kinds of resource allocation. Okay, so you can think of Yarn as like a network. It's a distributed operating system. Okay, you can think of it that way. Now, because of this segregation of MapReduce and Yarn in Hadoop 2.0, Suddenly there were so many applications that came in who were competitors of MapReduce in a way, but their objectives were different. The most important out of the competitors became Spark. So, all right, all right. So, Srini, we will get into the details as in what does exactly happen in case of Yarn. There are many more details to go ahead with. Okay, so Murkesh, could you reframe the question, please? I've lost your question amongst 4 5 chats. So please, could you do that? It's a little difficult for me. All right. So this is clear, right? In case of Yarn, basically the biggest change that happened was converting Hadoop 1.0 was to break down MapReduce into two parts. Okay. One became the logic part, as in the paradigm part, where uh, exact semantics of map and reduce, and the rest of it, the common phenomena of scheduling, common phenomena of tracking the resources, all of that were extracted out so that it can be utilized by other programs as well. And that is why today we have lot many things running on Yarn. The many things that run on top of Yarn. MapReduce just became one use case of distributed computing. So it's the Yarn, the heart of the whole thing, which is being utilized, which is running on the cluster. Okay. Now the what does now more details about Yarn and MapReduce. So the Yarn was created so that we can support workloads other than MapReduce. Scalability, as in it can now more and more applications could be built on top of Yarn. It's compatible with MapReduce, as in whatever MapReduce was there already, it will run as such. You don't have to rewrite your MapReduce functions. Now, it improved the cluster utilization because there are many form of computing came in. So as of today, our cluster runs Spark as well as MapReduce on the same machines happily. Okay. And H-based MapReduce also is parallel to normal MapReduce, and that too runs happily. So also the Yarn started executing really nice things, including HBase itself. HBase runs on top of Yarn and HDFS. That is something marvelous about Yarn. Okay, so it provided agility. It provided even Yarn started giving executing things which run forever, such as a database. A database runs forever, and those kind of things also Yarn has supported. Okay, so whatever we called the job tracker used to take the job from you and execute it on task tracker. Job tracker became the resource manager. This is what job tracker became, and application master and timeline server. So they broke job tracker into three parts: resource manager, application master, and the timeline server. Okay, task tracker became something called node manager, and a slot became a container. We will talk about these details. All right. So this is the architecture of Yarn. So here you can compare. This is a very simple architecture of Hadoop 1.0, where client used to ask job tracker to get the things done, and and this user will get the things done. This job tracker will get the things done on task trackers. In case one task tracker goes down, it reassigns to some other task tracker and get it done somewhere else. Now, in case of yarn, client asks the resource manager that, hey, I want to execute MapReduce. Some other guy might want to ask the resource manager that, hey, I want to execute my Spark program. Now, resource manager creates something called application master on on node manager. Application master is the application, what do you call, the owner of the application. Okay, so there will be one thing called MapReduce master, and then there will be something called Spark master. So every program, every kind of program you execute, there will be a master for it. Node manager is a general resource manager of particular node. So resource manager will ask, okay, so you can see that resource manager is the central agent who manages and allocates resources. All the clients talk to resource manager only. Okay, and there are application masters. So when you are executing MapReduce, first thing resource manager has to do is create an application master for MapReduce. Okay, so resource manager will ask node manager, can you please create MapReduce application master? And then after it has created application master, then application master will execute its code within the container. Okay, these containers are the actual executors. So application master is again doesn't do much, but tries to execute the logic inside the containers located near the data. So containers are application master will find out the containers which are or create the container near the data and execute your logic. Okay, so there are, it sounds like bureaucracy, but yeah, this is multi-level of delegation. You asked resource manager to do something, resource manager gave it to application master and node manager. Node manager is responsible for giving you the access to the resource on a machine, and then application master will talk to node manager, will talk to resource manager, will get a container created, and once the container is created or multiple containers are created, then it will execute your logic here. And on what basis the containers are created? Application master, if it's MapReduce application master, it will talk to all node manager and resource manager to locate all the machines which contain the data and are free. So application master is quite a responsible, uh, here, is responsible for doing all things. Application master contains logic for executing the application. All right. So application masters are responsible for the application's life cycle. When does the application start? How does it start? And when does it die? And also task scheduling, as in get scheduling various kinds of tasks. Okay, so there will be Spark application master, MapReduce application master, and whatever framework will come will bring their own application masters in future. And the node manager is per node agent. This guy, node manager, is responsible for this whole node. Anything that needs to be executed on this node, you have to first consult the node manager. All right. All right. There's a question from Srinivasan. What is the difference between split and block? So if you understand, if you remember, when When we were storing the data in blocks, it was cut exactly at 128 MB. It did not care. So that was block. Okay, block may not have correct boundaries because it might be the block preparation might be block boundary might be in middle of the record. Okay, let's say you're storing a CSV file and it has two blocks. So this block, one block might contain half of the line and a second block might start with half of the line. Therefore blocks are not consumable. Blocks on blocks you cannot run programs. For that you need another program to convert blocks into processing forms. A program that converts a block, the raw data, into records. Okay, that's called input split. We will go into the details of input split in next session. Now, this input split is basically a composition of records. Okay, you can think of input split as if it's a big table containing only complete records, not partial records. Okay. For converting blocks into splits, it requires a lot of effort and sometimes a network transfer also. Because some part of the block might be in another, some part of the record might be in another block, and some part of the record might be spread across multiple blocks. Therefore, sometimes whenever we are doing the computing, we need complete record, and this definition of record may vary from one MapReduce to another MapReduce program. All right. So that was the quick answer. Okay. Murkesh, you got the answer. You got the answer, or should I repeat this one? What is the difference between job tracker and MapReduce? All right. So this is already clear. Good, good. All right. There is a very good question. Thank you, Anand, for asking this. Here is a good question from Anand. Question is, one block is equivalent to 128 MB, but the actual file is only 50 MB. Even in that case, HDFS splits the file and stores in different node? No. In that case, it will have a single block of 50 MB. Okay? And it will be stored on of course data nodes, and there will be replication. Okay, so it will behave, yeah, the usual one. Even if it has one node or one block, it's complete, it's perfectly fine. Okay, moreover, if even if you have bigger file which spans across multiple blocks, the last block is going to be generally this smaller than 128 MB, because not, I mean, there'll be only very rare chance of getting a file which is multiple of 128 MB. Therefore, the last block is always smaller. Now, Murkesh's question is, why don't we see container in the second node? Maybe for this particular execution here, there is a container so there are two works happening here. One is first client wanted to run MapReduce. Second client came and he wanted to run Spark job. Both the things are happening on the same cluster. Okay, so whether you're writing programs in MapReduce, I mean Hadoop's MapReduce, or you are writing programs for Spark, all of that is happening here. You can see one color and another color. Okay, so this particular job needed just one container because the file there was only one block to it. That means there was only one node containing the block, and therefore it's executing only one container. But the second job needed many machines. So second job needed one, two, three containers. Okay, it needed parallelly those many containers. So those many containers are being executed. I hope now the diagram is clear to you. Uh, okay, all right. Now, every data node has a separate node manager. Yes, every node has got a node manager. All right. There is one more question from Srini. Each node have app manager and container. Okay. Application master basically you're talking about, right? Each node has application master and container. Those only responsible particular node or all of the node. Okay, so yeah, so node manager is only responsible for this particular machine. Okay, this particular node only. Now application master is per application. I wanted to run my MapReduce job, so to coordinate with my MapReduce tasks I need a somebody, and that somebody is called application master. Okay, so application master is responsible for all the work that is being done for this kind of application. Okay, for MapReduce application master or MapReduce master will be responsible for all the executions done for MapReduce, while I mean, the application master for, let's say, Spark or HBase will be responsible for all the containers that are being executed by for this particular work. Okay, so the program, yes, Murkesh's question is the program needs to run on all the nodes. That is correct. Now, so for this particular MapReduce, maybe there is only one block that is being executed. Okay, it is up to the application master to request that many containers. If this application master realizes that the file it's trying to process is on these three places, one, two, three, it will create these three containers. If this application master realizes that it has only got a smaller block, it will create only one container. That is the reason why you see one container for one application master and three containers for another application master. Okay. Can application master and container reside in the same node? Yes, based on the resource availability. That exactly is the job of Yarn to figure out for you. Okay, all right. Yes. So application master and container does not need to be on the same node. It can be on different, it can be on the same based on the resource availability. So yarn resides on name node. Okay. Do you mean to say resource manager resides on name node, Rohit? Yeah. So it sounds like resource manager would be located on the name node, but it will be too much to ask. Okay. It will be too much to ask. It can be resource manager needs to know, resource manager needs to know name node. It doesn't need to be co-located with name node. Okay. All it needs to know who is the name node, and in case that name node contains our data which we want to process, because application master will ask resource manager, can you give me the resources which are closer to this file? So client who is trying to execute something will come to resource manager and tell, can you execute my program? Or the application master will tell that, can you execute, give me the containers. Application master will ask the resource manager, can you please give me a place to run my program, which or places to run my program which are closer to this particular file. Now resource manager knows which machines are busy, but it doesn't know where are the files, so it will ask name nodes, can you please provide me the IP address of all the machine that contain this particular file. Now name node will tell resource manager that this list of blocks which your file has, and these are located on this machine. And now resource manager will also compare this list against which machines are free, and it will return the list of machines which are free and are closer to the data. Okay, so this is what keeps happening all the time. So client asks for running MapReduce. Resource manager will first create an application master for MapReduce. Their application master will further talk to resource manager, can you please run my program near to this data? And then resource manager will execute that program, and application master will talk to all the containers which are being run for that particular program and will give you the results. So yeah, there is a point that app master and container under control of yarn. Yes. Okay. So zero client asks MapReduce task execution. Okay. To resource manager. Now resource manager creates the MapReduce application master. Okay. And then application master requests resource manager to give containers near the given files. Okay, so application master will AM will ask resource manager to give containers. Containers are placed for containers are the units of execution, as in run the program inside here and near the given files. Okay, so and then resource manager will talk to name node name node and node managers to create the containers. Sounds good to you? And fourth is application master runs the program inside containers. This is what keeps going on here. All right. Now there is a question from Sumati. Why are there two containers? You see, there are two containers here. Two containers for the same application master, the third node. Is it running different tasks of the program at the same time? Yes, it might be. So it all depends upon application master's need. Application master must have realized that one of the container is reading from the disk, other container is doing some processing from the network. Therefore, let those two containers run parallelly. So that is the job of application master to decide. Now, question from Dirpu is, how significant is that the container need to be near to the files? The container, it's a requirement imposed by AM. Your application master, if it doesn't want the locality, it can tell the resource manager that, hey, I don't want locality, just give me containers anywhere. All I need is 500 containers right now. Okay, so it's a significant imposed by application master. Okay, is a significance imposed by application master. Sometimes if it is not available the containers, it will give the results that, okay, we could not find the free containers available near to your blocks, so please live with the nearby one. So it will give you the nearby nodes which are free and are nearer to the data. Now, question is, why is the container not created in the same name node where application master runs? Okay, because container. So generally, application master is only single. There's only single instance of application master, while containers could be many. Containers are created near the data, while application master can be created on any of the node. All right, makes sense to you, Mukesh? No? Did it make sense to you? Why is the container not created in the same name node where the application master runs? So application master runs on only one machine. Okay, but containers we need many, and the actual work is done by the containers, not the application master. Okay. So there are no multiple name nodes. You cannot have two name nodes. There are only two data nodes. Probably you are saying data node 2 and 3. All right. So see, what exactly are we trying to do? Hi. So let's take a break and then come back. Probably, yeah. Let me try to explain. This is important, and that's why we need to understand it. Okay. So yeah. Hello everyone, can we start now? All right, all right. There's a question from Anand. Let me try to answer that question. Question is, can a same node manager have more than one app master? Example, maybe, yes. Answer is maybe, based on resource availability. Now there is a question from Murukesh. Question is, assume the data is split between data node 2 and 3. Okay. All right. So I think should we go over this flow again? Okay. Let me see. All right. Yeah. Okay. So so Murkesh's question is, assuming the data is split between data node 2 and data node 3, which is node manager 2 and node manager 3. Okay. So here basically let's assume the data node 1 is node manager 1 and node manager data node 2 is node manager 2 and data node 3 is node manager 3. Okay. So what exactly happens? So I will just try to see if I can scribble somewhere. All right, let me try to scribble somewhere. So here, this is the first request. Okay, this is the first request. The client has asked resource manager that get my work done, and my work is in the form of this application master. So this application master, once it has created, client client will ask resource manager that this is my work. My work will be in the form of one code which defines application master, and rest is the data required by application master. Application master would contain the code inside the whole logic, the whole framework of MapReduce. The whole framework of MapReduce will actually run inside application master. Okay, so application master is essentially the node which is responsible for doing the part of the job tracker work. Okay, part of the job tracker work goes to application master. So the work which was earlier done by job tracker alone in case of Hadoop 1.0, it is split between resource manager and application master. So application master will contain all the map reduce logic, such as finding the nodes which are closer to finding the data nodes which are closer to our file, and then executing the work there, running maps, running reduces, and all the things which are done. So first client requests resource manager to run the job, then it creates application master, and then application master asks resource manager for creating the containers, and the resource manager will ask node managers to create the containers. Master asked resource manager, and resource manager asked node manager to create the containers, and once that is done, it creates the containers, and then
containers will start talking to the application master, and this is what goes on. Okay, you can think of this in a federal government. You have a central government, okay, and you have these state wise. Okay, so this guy node manager is the guy who is a state-wise government. So if you have to get anything done on a grand scale, you first go to the central government and ask, request for central government to redirect you to the state. This guy is your state chief minister or somebody, and then this will communicate resource. The communication between resource manager and node manager happens between like central and the state-wise agencies, and then and once and then the rest of the work like creating containers, not creating containers, that that all is duty of the application master. How many containers it want, it will inform the node manager and then establish its work. Okay, so you can think of this particular client as somebody who is running an NGO, wants to set up a factory which will run the work somewhere, and first they go to the central government redirect to the state government, and then gets the work done. Did I make sense now? So these marks which I'm giving, these are steps. Okay. Yeah, application master can be created in step number 3. Yeah, application master will be created anywhere. Okay, it all depends. It can be created node 3, node 2, anywhere based on the availability of the resources. Okay, so when client goes to resource manager for the creation for running its job, resource manager figures out. It also tells resource manager that, hey, I need this much of RAM. This my program might require this much of RAM, and for application master. Okay, so resource manager goes to the node managers and figures out which machine has got the biggest RAM and runs application master there. Now, application master will tell resource manager, can you give me 10 containers? Application master asks resource manager afterwards, once resource master has been established and running. Once application master is established and running, application master asks resource manager that, hey, can you give me 10 containers which are closer to this particular data? or or it could also ask, just give me any random 10 containers. I don't care about data localities. It is up to application master to request the resources in that manner. All right, so now I hope you are getting the concept. So it's a standard process. If you yourself have to design a similar system, you would probably design in the same manner. Okay, because this is not only for one kind of job, this is for all kind of job. And what exactly goes on in the job, how it runs, and what exactly goes on in the job, you need a per job master, that's called per application master. And and that application master has to talk to its own distributed components. Okay. So Anand's question is here. His question is, every job have an application master, or every type of job. Okay. So if you have run MapReduce already and it's running, now next time it runs, it will use the same application master. Okay. In case the application master is already running, it will utilize the same application master. Now, question from Srini is application master required to reside inside node, or it can move to any node? It has to reside on any of the nodes. Okay. Now, question is, can it move to any other node? Yes. It can move to any other node. In case one node goes down, let's say this node on which application master was running and there was a container running, this node goes down. What it will do is it'll first relocate this application master somewhere, okay, and then whatever containers it was running, okay, application master will be informed that your container is down. Okay, then application master will ask again that can you create the same container for this particular block, and then it will create another one. Okay, is that clear now, Murkesh? Also, application master doesn't care too much about data locality. It is the container that needs to be closer to the data. All right. All right, let's move on. This is the same flow which I have been describing. So application is asking resource manager, submits the full yarn application. This is resource manager. And now resource manager will ask node manager to start to launch a container for and this application process. This is the okay. So once this runs, the container runs, then it'll talk to node manager and can start another process. Okay. All right. Okay. So when you are making a request to the yarn, it's called a resource request. You basically are asking yarn to give you some resource. The resource might include number of containers you want, or how much memory are you going to consume, or how much CPU are you going to consume. Are there any data locality constraints, as in do you need the containers near a particular file or not? Okay, so those are called locality constraints. And then either do you want containers upfront, or do you want containers as you go, as in do you know upfront that how many containers you will know in future, or you will keep asking for containers as and when you want. Okay, so those are the two things. Second is application lifespan. You also tell Yarn how your program is going to run. Is it going to run forever? Is it going to run once for all similar kind of tasks, or it is going to run separately for each task? When two people are submitting MapReduce, will there'll be two map application master or one application master? That is decided by application lifespan. Okay, so the application lifespan can vary too dramatically, as in one application is running forever. For example, HBase also runs on Yarn. HBase has got a HBase master. Okay, And there are region servers. Region servers are actual workers, while HBase master only coordinates between these region servers. So HBase keeps on running all the time, 24 by 7. So that application lifespan is forever. While the for MapReduce, it's you submit the job, it'll get the job done and will report back. That is that is batch wise. Now there is another kind of it which is session wise. Session wise is that you create a workflow and then you keep on running it unless it is dead. So in case of kind of a MapReduce, where the simplest case is that application is per user job. User submits a job gets done, application everything is deleted. Okay, as in container is deleted, application master is deleted after the job is done in case of MapReduce. Now in case of Spark, now in case of Spark, it runs till the point session runs. It's one application workflow per or user session. So you connect to Spark Master and then you keep on working. Keep it gives you a console, it gives you a command line, and it keeps you keep on talking to it. So Spark Application Master is kind of a little long running. It runs for a while. Okay, this resource request is being raised by your application master. Okay, now your application or application master could be long running, could be short running. Long running could be something like Impala, HBase, or Slider. All right. So this is the anatomy of yarn. So we talked about the whole structure, how it happens, and when application master is asking, or this resource manager is being requested for resources, these are the types of requests along with the application lifespan. We tell here the application lifespan either upfront or as we go. Okay, lifespan constraints. Okay, not really. Let's just leave it. Okay, now in case you want to build your own yarn cluster, you can first try to use existing frameworks such as MapReduce, Spark, etc. Most of your work actually can be done using any of the existing frameworks such as Spark and MapReduce. Second, you can try to utilize existing tools. Okay, there are existing tools which can help you build the jobs such as Apache Slider and Apache Twill. All right. Otherwise, you can build it from the scratch, although it's little complex. Yeah, although it's fairly complex to build a application master or your own kind of application from the scratch. Okay, though Yarn gives you a bundled example called distributed cell application, you can start from there and build your own kind of framework. Okay, if you're interested in building your own kind of framework similar to MapReduce, you can start with in this manner. Okay, all right, all right. So Murkesh has a question. If you have data in Node 2 and Node 3, can application master run in Node 1? Yes. Okay, because application master does not ask for data localities. What it wants is the containers will be in Node 2 and Node 3. Okay, The actual executors, application master will not be running your MapReduce code. I mean, will not be churning the data. It will be the containers. All right. Yes. Containers will run the actual logic. That's correct. All right. So application master would look like as if it's a job tracker who is not doing anything but just coordinating between maps and reduces. All right. So is it clear the architecture of Yarn? Should we proceed? And yeah, we will just do a hands-on now. All right. Uh, Earlier, we had gone through the web interface of Ambari, Hue, and connected to the cluster. We made a directory at HDFS. We now want to run the MapReduce command. Okay. So question is from Anand. While execution, is it possible for us to monitor the app master and the respective containers? Maybe through some monitoring. Yes. Yes, it is definitely possible. I'll show you that. Now, question from Rohit is node manager equivalent to individual data nodes? I'll answer it this way. Node manager is a process which process as in operating systems process, which runs on a machine, just like just like data nodes. Okay. So the way the practice is to have data node on all the machines. In the same way, we have node managers are installed along with data nodes across the cluster. But it's not mandatory. If you feel that one of the machine is not having good CPU, okay, does not have good RAM, you may skip installation of node manager on that particular machine. Okay. Hello. Hello. All right. Hi. Is All right. So there was a slight fluctuation of internet because of which the it must have got disconnected. So all right, coming back to the question what we had been talking about. So if any of the container has failed, it is possible to start from the point of failure? No. So every container is working on something. So application master has assigned some work to one of the containers. Maybe it's running the maps of your program. Now, in case this container fails, okay, whatever data it might have had churned so far, maybe it was almost about to finish the process. Okay, it has to be restarted. Okay, mostly it is the job of application master to see if it can be resumed or it has to be restarted from the beginning. Okay, mostly most of the application masters, they restart the container rather than starting it from the point where till from the point where it has got stuck. Okay, so containers are generally restarted. Sometimes some clever application masters will basically able to resume the containers. Okay, all right, very good question. Any other question before we move? All right, let's try to run the map reduce. Okay, all right, all right. Let me just run. Okay, all right. Let me log in into Ambari and then see if we can. We have Hue. You can see that. Okay, here is your HDFS. This is your HDFS, and we will use one of the consoles. I think it has disconnected. Is the font clear to everyone? All right. Okay, so I'm just on H3. No worries. Good. So Hive is down, HBase is down. Never mind. It doesn't matter. Right now, all we require is my MapReduce and HDFS. Okay. So there are three data nodes, and as part of yarn you can see that there is resource manager and there is a node manager. If you click on resource manager, you can see that it's running on this particular machine. Okay, and I don't know what does it mean in terms of h2 h1. Okay, now we have node managers. There are three node managers, one resource manager, and application master will be created only when we run the program. Okay, it's not installed by default. Application master is not installed, only the node manager, resource managers are installed. Okay, all right. So the way we run our, are you guys with me? So we are going to run our MapReduce program just to understand what's going on. So let me just quickly explain to you. So right now, when you look at the diagram of this resource manager, it looks a little scary. But good news is that we don't generally need to know the internals of the yarn infrastructure. Okay, we just don't generally don't need to know. We just generally need to know that anything we run on yarn runs in the network. Okay, all right. So here is an example program available from Hadoop team itself. Okay, generally wherever you install Hadoop, inside that folder, inside Hadoop dash MapReduce, you get this example jar. Okay, so we are saying same command Hadoop, instead of saying fs we are saying jar, and then we are providing this program. Now this program contains your logic. Also please note that this jar file, what exactly is jar file? Jar file is a bundle of code. It's like a zip file in which all the folders are compressed into one file. Okay, all folders and file structure is packaged into one file, and this file contains your MapReduce logic. We'll go into the details of how to write maps and reduce. That's a detailed discussion we will have. Okay, so this is the MapReduce program. Okay, now after this point, whatever you provide here on the command, they are the arguments, they are the options to this particular program. Okay, we are saying take this command, take these examples, run the example called word count. Okay, and this is my input directory and this is my output directory. Okay, these are the arguments taken by this program, and this program is our examples. All right, now let's try to run it, although it will give an error for the first time, but let's see what happens. All right, oh, it's running the job. I thought it will fail. So basically we are trying to do the word count of this particular file. Let's have a look at this particular file, and we are trying to put the output in mrout. Okay, so let's go here, go to that particular folder. Okay, data. Also please note that anything which we will learn in this session is located in data folder. Okay, the older data of HDFS and local data I have copied here in case you are interested. Okay, these are the older HDFS data. Now here in this folder you will see all kinds of data. You have MapReduce data, under which you have word count. In this is the file which we are talking about, or we are just talking about input folder. Come back. So we don't need this file, it is just useless. This is the one which we are trying to, but notice that we have only set the folder. Okay, we have only set the folder. So folder means all the files in this particular folder will be considered while running the MapReduce. Okay, so it will basically do the whole job of first creating MapReduce application master, and that MapReduce application master will take this jar file and run this jar file on various containers. Okay, and whatever is the result, it will store it in this particular folder called mrout. Now important thing here is, though For the input folder, we are providing the exact location, not relative location. We are providing absolute location. Here, this folder is not starting with slash. So where does it create this one? In the home folder. Here, this is where it is going to give us the results. Dirpu's question is, jar is the only extension that we can use. Yeah, for in this Hadoop jar, when it asks for jar file only. Although even if you rename .jar to something, it will still work. Okay, so as long as it contains your MapReduce code, it will work. So Anand's question is, what exactly is this word count? Yeah. So word count is an argument to this program. This program. If you look at the source code of this program, it will be reading the arguments and then saying that if argument 1 is equal to word count, then run the example called word count example. Okay. So you can see that this contains the output. Okay. So it has generated the output in this folder. Okay, so it has basically done the word count on the data which we had here. Okay, the data which we had at this point. Oh, why it's not going back? So whatever data we had at this point, not this, sorry. Yeah, in this folder, whatever data it has churned that and converted into this particular file. Sounds good to you? So if you, yeah, if you want to put it in some other folder, you can put some other name here. Okay, you can, let's say if you want to put it in Dirpus folder, okay, you can put here like this. You can go here again. Also note that the once it finishes the job, it gives you the complete detailed statistics, and these detailed statistics are uh, you can also look at the overall progress here, and this is all right. We need to change these machines name. We need to change these machines name. It's a little too tricky right now. We basically need to note down the IP addresses of these machines. Okay, and how can we do that? This is what? This is our H3. Anyway, we'll do that later. This is our H3, and okay, we will do that later, probably whenever we have time. Okay. Okay, so here there are a few questions related to the output folder. I'll clarify those. So here, if I give the same mr out again, it's going to give me an error because that folder already exists. It is saying it already exists. Okay, you have to always give a fresh new folder name. Also, instead of giving it relative, we can also give it something like user slash, and what was the name of the folder? This one. Okay, we can even say things like this. Okay, instead of mr out, we could have said this way. Here, let's say we are saying user this and mr out one. Now it will create another folder in our home folder. Okay, we can also create subfolder. Any folder we have permission to write to, we can give it here. Okay, so you can even create it in temporary folder if you want, but it's generally recommended to keep the work in your own folder because that you might pollute other people's environment. All right, here you can see that it has completed. Well, as you can see that once we run MapReduce job, it shows that this much percentage map, this much percentage reduce, and so on. And the URL again is available here, and you can see the overall statistics. Okay, we will go into these numbers once we discuss MapReduce. Okay, all right, so that was our quick demonstration of MapReduce. Even if you did not understand it, don't worry. Okay, we will go into more details as we go forward. All right, the idea was to just give you an idea that it's actually very straightforward to run a Hadoop MapReduce process. Okay, it's quite straightforward to run a Hadoop MapReduce process. Okay, so again, out of this is the Hadoop command. Okay, the command which is the gateway to file system and MapReduce. If you put jar here, if you put fs, you are talking to file system. If you put jar, you are talking to the MapReduce. Now, if you put jar, then you have to provide the program in the form of jar. Okay, now afterwards, after this point, whatever you provide is the argument to this jar, and this argument could be anything as expected by this particular jar. All right, now one more thing is that this jar has to be located in the local file system. Okay, local file system, as in when we pick this jar and say Hadoop fs minus ls this. Okay, it says no such file or directory because it's not there in hdfs. It is available in local file system. You can see that it is available in the local file system. Okay, while this particular folder this particular folder is in hdfs, the data is in hdfs, the program is in the file system. So if you say ls minus l, it'll say no such file exists. If you say hadoop fs minus ls and you say this, okay, you can see that there is a folder containing a file called big.txt. Make sense to you? And in the same way, the output also is in the HDFS. All right. Anand's question is, can you please give a quick definition of what is map and what is reduce? Okay, so we'll go into that. Just give me a second. So map is, so your data is first cleaned through the map and then aggregated together, and then on each aggregation you run the reduce. Okay, so you create a map program which runs against each record in your input data, and map provides a way to sort the data or group the data based on a particular column or the key. And so map gives out the criteria for grouping, and before the data goes to your reduce process, Hadoop groups your data. So Hadoop essentially groups the data, and for grouping, it figures out what key is to be used for grouping based on your map program. Okay, and then on the output you run the reduce for each group, as in for each key and all the values. Don't worry about it. We will go into more details, more examples, and then you will have a clear picture of what we are talking about. Okay, so everybody is able to see how we ran the map reduce process. Okay, if you guys want to run it, I'm just sending the command to all of you. All right. Okay. So are you guys trying this command? Yeah. So Dirpu's question is, why is it giving a warning? Because now you can run your program using yarn also, because internally it's calling yarn only. Okay. I have not tried with yarn. Let me just try with yarn. Okay. Here it is. What happened to this? All right. You can you hear me now? I hope you can hear me now. All right. So Srini, I'm extremely sorry because the network fluctuates for a second and my whole thing goes haywire. I'm really sorry. Okay. D- uh, Now, Srini, you can try Control Shift V for pasting. Is it working? The command which I have pasted in the window, I'm asking you to execute that. Okay. Or can you just press the up arrow key and you will be able to see this command in the history. Are you able to get it if you press up arrow key? Yeah. All right. So this one, let me, I was actually trying to show you. Yeah. All right. Okay. Now go back here. Copy. Okay. So are you able to go up in arrow key? It's not there. You can also press Control R and there you can say Hadoop jar. It's not there. In H3, it's not there. Let me try with H3. I'm trying to log in on H3 and again 7974 T7974 T7974 and yeah. So if I press up, yeah, here it is. So yeah. So we were talking about executing it through yarn. I think it should be the same thing. Yes, it says it exists. All right, now it's working. Okay, so what I was saying is that in case you are not able to copy paste, you can press up arrow keys, go to the history where I have tried to execute Hadoop jar, and then try to use that command. All right. Good. All right, so that was a quick about MapReduce. So I think we should get into understanding what exactly is MapReduce now. All right. So Srini's question is there a permanent solution to paste on Windows? The Control Shift V used to work fine. Control Shift V used to work fine. I need to see what could be done. All right. Is anybody able to copy paste in Windows? Srini, are you using Chrome? So Srinivasan is able to copy paste, and Srinivasan, you are on Google Chrome, or Shashi is not able to log in. Log in as in on the terminal, Veti, by copy pasting. Yes. So Srinivasan says that he has used it on Chrome, Windows, and the Control Shift V is working, I think. Rohit is saying I'm able to copy paste in Chrome using. No, I'm talking about the Veti. We are talking about this Veti. Are you able to copy paste here? Try Control V. Never mind. So yeah, I'll try Srinivasan later. Srini later. You can. Sashi, try both Control V as well as Control Shift V. The password will not be visible. You just have to press Enter. Okay. No, and even asterisks will not be visible. You just have to press Enter. All right. Now coming back here. Okay. All right. So let's start with our discussion on MapReduce, and then we will. All right. As per Rohit, he is able to copy paste in Chrome using Control C and Control V, and he is accessing VATI. Okay, so please you try Control V or Control Shift V. I'll also try after this session. I don't have Windows right now, but I'll get one and try. Okay. All right. So that was about the yarn part. Now let's move on to MapReduce. Okay, so MapReduce is basically a way of solving problem, a paradigm, a framework to solve our problem using so many machines. Okay, so far we discussed about how one program gets executed across multiple machine and this and that. But how do we divide? How should we structure our program such that it runs on multiple machines? Okay, such that how should we structure our program such that it runs on all the task trackers or all the containers, uh, and churn the data in parallel. That's what we will learn in MapReduce. So the way we used to write queries, SQL queries, to clean up the data quickly, the way we have been doing other kinds of programming for different use cases. MapReduce is similar. MapReduce is based not a new programming language, it's the same programming language, just that you write your program in two parts. One is map, other is reduce. These two parts get executed at two different times. Okay, we will talk about this uh, as we go forward. All right, now let me ask you a simple question. If you have the plain text file of all of the Lord of the Ring books, how would you find the frequencies of words? Anyone? Yes? Srini says by using sort. Anybody else? Murukesh says that go through the text, come up with the key value pair. Okay. Okay. Interesting. Interesting. I think I should copy paste the answers. These are nice answers. So Srini's answer is by using quicksort. Murkesh's answer is go through the text and come up with key value pair, and then continued is for each word occurrence. Okay, go ahead. And then Rohit's answer is okay. Anand's answer is by grouping. Brilliant. All right, these are very brilliant answers. Okay, all right, all right. So this is Pankaj's answer. Split each word with a space and take each word and count that from an array. Put each word as a key in the map and count as the value. Perfect. Perfect. Now we have another brilliant answer with sort and unique. Brilliant. All right. We will actually take these two three approaches in our further discussion. Okay. So yes. So this is what we do. So let's talk about the first approach, which Pankaj and Murkesh has said, that you create a frequency hash table or a map or kind of an array where key is the word and value is the count number of times a word has occurred. So initially this hash table will be empty, and as you go through the text file you keep adding the word to the dictionary or updating the count or increasing the count, and then once we have read the whole file we print this hash table. Now Is the approach clear to everyone? Is the approach clear to everyone? All right. All right. Do you see any problem in this? Do you see any problem in this? All right. Okay. All right. Think about this problem. Okay. Think about this problem, and those who want to do the hands-on on HDFS or MapReduce, they can. And if you have 15 more minutes, you can do now. I will be in this session for next 15 minutes, and I will make one of you the presenter. Okay. So if you are interested in doing hands-on, we can do it in next 15 minutes. All right. After 10 o'clock. Is that okay? Okay. All right. So Murkesh, with this whole session will be recorded and will be available to you, and then we can have you can have a look at it. All right. So okay. So let's do a hands-on exercise for in 15 minutes. Okay. Here are few things you have to do is first upload a file in HDFS. So this discussion on MapReduce we will continue in next session. For next 15 minutes, this extra 15-20 minutes we will spend on hands-on. So let's try to do upload a file in HDFS. Okay. So before that, first create your folder in HDFS using Hue. Okay. And then under that you upload a file in HDFS using Hue. Okay, is everybody able to do that? Two steps. Step Step number one, you create your own folder in the home directory using Hue. Let me take a look. Anand has done, and put this file, upload in this file whatever we talked about. Okay, in file inside your folder. Okay. So I see only Srini, no Srini, Dirpu, this. Okay, okay, nice. So many people have tried MR, this thing, and I'm moving. Okay, somebody has uploaded a music. Guys, you'll have to delete the music, and you will have to delete the. Yeah, you'll have to delete this music, and all right, or yeah, good, good. Let me keep having Hadoop Is it disconnected now? All right. So if you are stuck, then raise your hand. I will have a yeah. Hello. So are you done? Should I have a look at it? Please raise your hand if you get stuck somewhere. Are you able to hear me? Can you hear me? All right. All right. So good. Everybody is able to create their folder. Please, in case you get stuck, you are not able to proceed. Please raise your hand. I'll have a look at it. Any file which is not some confidential data, you can upload. Okay, so nobody is raising the hand. I'm assuming that everybody is able to do. Okay. All right. Now, one more thing. So once you are done, now, all right. Okay, so everybody is able to do create a folder in Hue and create a file in HDFS. Are you done? Anand is not able to hear. Anand is not able to do. Okay, Anand, this one, Anand. All right, exercise word count. Good, good. So I uploaded a file. Good, awesome. So everybody is able to do that. All right, now let's go to the command prompt here, the console, and there T7974. T7974. Here, what we need to do is we have to say Hadoop fs minus ls, and I can say lrt. It doesn't have those options. Never mind. Now, using Hadoop fs, let's download a file from somewhere. Let me also create my folder. Let me create my folder. I'm creating my folder, and yeah, and also uploading my data in this. Then what we'll do is we'll use the command prompt. I'm just using, let's say, now here I can see Hadoop fs minus ls. Okay, you can see as Giri. What if I have to see something inside as Giri? I'll say Hadoop fs minus ls as Giri. Right now it's not uploaded. It maybe take some time. Now it's uploaded. Now let's say I want to copy this file locally. Okay, from HDFS to the local folder. So what do I need to do? Hadoop fs minus copy from, okay, copy from local, copy to local, copy to local, and then whatever directory it is, that file name I say, or I can also say things like asgiri slash star and dot. And instead of dot, let me first make my directory mkdir. I'll say asgiri local. I'm creating a local folder in this particular computer, not in HDFS. And then I will run. I'm saying Hadoop fs copy to local asgiri slash q. Although it has copied the file, but it some gives some warning. If I say unzip, yes, it has unzipped the file, which means file has been successfully uploaded. Okay. All right, I've deleted the file. So you also can copy the files in the same manner using Hadoop fs copy to local like this. Okay, done. Anyway, console, and you can use any console, H1 or H2. Pankaj, either you can give me a call or you just drop your questions over the email. Okay, and then I'll reply to it. If it's not clear over the email, then we can discuss over the phone. All right. Pankaj has got some questions. So anything with whatever you uploaded in Hue, I want it to be copied onto the local machine, just so that you understand the difference between local machine and the HDFS. So you uploaded something from your desktop, it went into HDFS. Now you taking it to the console. I mean to the H1, H2, H3 or whatever machine it is. All right, are you done? So use this command copy to local to copy your file to the local folder. So did you upload your file? I uploaded my file here in Asgiri inside this. Now I am logged in onto Vati. I'm using this command called copy to local to copy that file from HDFS to this h3.cloudxlab.com, that machine. Okay. You also do the same thing. Whatever file you uploaded, you copy to the local. So these are local files. I can see Anand, Carlos, Dilsad, Rohit, Steven has created the local folder. Yeah. Okay. All right. Good. Anand is able to copy. Done. All right. So if everybody is able to use Hadoop FS, copy from local and upload file, they can. I mean, they can ask questions. Or if you are not able to do, let me know. I can help you. Are you done? So if you are facing any difficulty, I can help you out. Yes. So not this. Yes, that's correct, Dirpo. That's correct, Dirpo. It says Hadoop FS copy from to local Dirpo stars. Yes, that's good. Okay. Copy your file. Don't. Okay. So Zuan is okay. Zuan, can you paste your command, please? So Srini, you have to copy your file from HDFS to local using copy to local command of Hadoop FS. All right. The way I did Hadoop FS copy to local and you and provided my folder from HDFS and then file from HDFS and then said dot, it copied. Ignore the warning for now. Yeah. Nano command doesn't seem to work. Let me install. Let me try to install Nano on all the nodes. All right, I'll install it after some time. All right, good. That's good, Steven. That's correct. Good. All right. Thank you, Zian. Thank you. All right. Any folder, Srini, whatever you want to copy from HDFS to local, you can do that. So, Shashi, you are getting the file exist error because you may be copying into my folder or in the home folder. Create your own local folder. The way I've created my own local folder, I've created, you can see, S Giri local. So I'm copying here. Similarly, you create your own local folder and copy from HDFS into that folder. All right. It's yeah. It's better to create a local folder so that everybody's work will stay separated. Okay, Dilsad's question is that he is trying to copy the file. Yeah, yes. So here you have to, yeah, this is correct syntax. Okay, this is correct syntax. Provided this Hadoop test is a file. If it's a folder, then you will have to put -r. Okay, to create a local folder, use a command. So I'm again showing, okay, let me just delete my folder. Okay, from the beginning. So first I created mkdir as Giri local. This is my local folder. All right. Then I went into this local folder by using cd. I said change directory to sgiri local. Then I'm saying Hadoop fs minus copy to local, and then I'm providing my remote directory's location, relative location, which is sgiri. You remember I created sgiri folder from the hue, and yeah, and so I'm saying sgiri and then q star. Okay, because my file starts with q, you can see that. And then I'm saying dot means my current folder. I'm saying copy this particular file which starts with q into dot, which is current folder. Okay, if I say ls, you can see that it has copied it. All right, Srini. Okay, so there are three things to look into on my side. To do is one, fix VATI for bigger timeout. Second problem was SSH not working. And third problem was Nano to be installed. Okay. Yeah. So Shia, there's not much of a difference between put and copy from local. Okay. Copy from local is just another alias to put. Okay, Srini, this time was it clear? These commands: make directory sgiri local, cd sgiri local, and then Hadoop fs copy to local from, copy to local HDFS folder, and then dot, and then there will have. All right. Okay, so this is how you can interact with the HDFS, and please try to execute that HDFS command which we did earlier. Okay, all right, great, 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 Shashi, you're able to copy. All right then, bye bye. Have a good day. Okay, if you get stuck anywhere, please let me know. Okay, you can drop us an email at Hadoop at no big data. Now you can finish all the assignments. You can finish these uh, quiz, and there was one more to do on my part. That to do was export latest PDF. Bye bye, have a good day. Yes, we will try to upload as soon as possible. All right. All right, Dilshad. Have a good day.